Alright, how's it going everyone? Welcome to another video, but in this case is looking at the React Dev docs as a way to make sense of once we know how this React rendering mechanism works, we can know how to improve that, which is part of this course. Taught by Steve Kinney, head front-end engineer at Temporal, which is now this open source durable execution platform that companies like Versal actually are using. So in any case, the whole point of today's video is to not only take a look at this last three sections as a way of understand briefly again the life cycle of our reactive effects, the separating event from effect, understanding that specific use case, and removing effects dependency by now then reusing logic with custom hooks as a way to now put all of this synchronization process that you can either stop or start into their own logic. So the goal of this course is to see how you can now write React performance application or components, therefore React applications, and see now from the experience of Steve, how can we do that? So he briefly described here is now what is React, what is performance, not only in life but also in software, specifically in React, and that is it is much more better to not doing, or it is much faster to not doing stuff than doing it, and there's some color that is to that. So you got now there's much more faster to do things later than doing it right now. And the idea here is that not only you can use this in your life as a way to prioritize things, but also in React as a way to now how the React community and the software developers, they now lay out the foundations to allow us this fine-tuned control over the rendering mechanism, or especially as a way to now allow us to improve the performance of our React application. Why is this? Because after all, React is just a UI. It allows to describe is a UI, which is they are just JavaScript functions where you can. So we look at how can we now import components, export components, pass down data to this component. Remember JavaScript function, as well as how can we now starting to show something to the user using the GSX, which is this markup language that also by showing us the rendering or these elements conditionally, or by rendering a list of elements, we can start to see how we can now is describing our UI, and therefore when you're defining your components, do that in a pure way. In other words, same input, same output. And there's some benefits that we're not going to discuss in today's video that that React community enforce you to actually do that. And then how now React actually sees your components as a way to now organize all of these different UI pieces into a tree data structure, or aka the render tree. And then you also have is the tree of dependency, which is the logic that you can apply to each one of these components as a way to now provide interactivity and reuse that kind of logic. So the idea of using is, or understanding is the render tree, is that now we can understand how the data flows through that, as well as the React performance. So when in any of these components actually is rendering unnecessary, for example, and when you pass some data or some logic to that, how you can now make it in a way that is reusable, or to get rid some code that you don't need it in your tree dependency. So by adding now the interactivity, which is the reason of why we actually are defining is our UI components using React, therefore they're just more boilerplate. This is just HTML uh, with more boilerplate code. So by adding that, we look at how can we do that using is event handlers, okay, and then passing that handle functions to the event handlers. And most of the time, because we wanted to show some data to the users that wants to keep sync or updated when the user performs some interactions. So, for example, in your bank account, uh, in your bank app, so you want to see your balance, your transaction history, your profile. So when you send money to, let's say, your mom, you say, all right, I want to know my balance updated. They want to see that state updated. And that's exactly what we are doing using is now the state. All right. So states is this way to react for remember things. So how you can now represent is informations that you want to keep synced, that you want to synchronize, you want to remember. So the way of how now you can update your state is usually inside of your event handlers that you set that state using the use state. And how now inside of the event handlers that logic is synchronous, and when you update that, the state values, the variable state value will be updated in the next render. So this next rendering or rendering is the mechanism that now React pass through anytime your update is a state. Your state is updated. So why is this? Because this is now the way of how by using is the React built-in tools, instead of you having to manipulate what elements or attributes or DOM elements change, you delegate that to React. So you can now focus on building your UI. And this render mechanism is made of three phases. You got the trigger, render, and commit. The trigger is, as the name suggests, when this state update happened. If this was happened at the initial render, which is the root elements, or at any of the components, or any ancestor component that state updates. And then on the render is when now your components are evaluated, aka so React is evaluating all of the props and in states, event handlers, reactive logic, and reactive values, something that we're going to talk about that later, if this is caused by a re-rendering. And then now what it's going to do is, well, compute that, store that for the next phase. And if this component has more JSX elements or more components, React components, it's going to continuously call that in a recursive way until there is no more components. And this is the process of when it started to recreate is the virtual DOM. And I'm going to make a pause here because this is one of the things that happened during rendering as a re-rendering, and the other is as the initial render when now the browser is mounting your entire elements. So if this at that time the initial render React will create now all of these elements using the create elements API, store that information to be used in the next phase. So on the commit, where now it has all of the elements that it creates, and now it has all the information, it's going to append that using the append on API in the DOM. Now it applies those changes in the commit phase, and therefore the React, or in this case the DOM, actually detects those DOM updates and then repaint your application. But if this was caused by a re-rendering, okay, now the thing here is, because on the previous steps the video was recreated, and this is just an ideal representation of the UI that is kept in sync, that is kept in memory and sync with the real DOM, and this particular process is known as the reconciliation process, which is also what guarantees you to don't have to manipulate the DOM elements, the attributes, and kind of things. So now you tell React which US state you want to be, and let now React match that state with the DOM. So that's why they have, for example, this thing called Fiber, which is in React 16, the reconciliation engines that now unlocks new things, new features. But again, it's features that are helpful for Facebook. Therefore, it might help you in your business, which is, for example, concurrent rendering using its transition, or rendering prioritization using use defer, these custom hooks or this built-in hooks from React, as well as the ability to now pause, stop, and resume a rendering. So the point of this is that because we are looking at this specific way of creating all of this kind of applications and so forth and so on, okay, now we make sense of how can we actually look at why is these tools are being created, and then how they're gonna sell these particular tools to startups, because this is now the business in per se. So there's a lot of open source tools that are backed by a lot of VC money, okay, and then wants to later on sell those tools to those startups. But the whole point of this is you want to solve is the problem. And again, that I know they are making things much more easy to manage, to maintain, that kind of thing, blah, blah, blah. But the idea is that if you are a company, you are in this compete mode with yourself and with the market, which of course improve not only the product, but also you want is to actually make it lean as much as possible. So right now I'm looking at React as a way to get a job. That's the whole point of this. And then find a way of how you can now using, for example, the solutions like PHP or Laravel, Laravel, okay, to actually build your server, okay. And I get it why a lot of people actually are using, for example, Laravel with Vue and that kind of thing, because now Laravel or this PHP server provide actually out of the box a lot of these things that you need to, that most of the time we need to: authentication, authorization, eloquent ORM, database migrations, validation, notifications and email, job queues, tab scheduling, testing, events, WebSockets. And again, they also follow is this strict they also follow is the strict that object programming and that kind of thing. Exactly. In Deutschland. this lightware is somewhat similar to what other people actually are building that for. Yeah, for sure. Because it summarizes a lot of this. So yeah, but in any case, but that's the whole point of this. That's the whole point of this. That's the whole point of this. And a lot of people are actually looking it for Laravel, MySQL, and PHP. Even in Motorola solutions, of course. Of course, Motorola are looking for that. And that's quite interesting. And that's quite interesting. Interaction Design Foundation. Exactly, because the vast majority of them actually are building that. And this is not describing that. The Interaction Design Foundation is something quite interesting. Senior PHP Laravel developer. And you see, all of this is that. All of that. There's a lot of people that actually they don't like PHP and Laravel, that kind of thing. But in any case, the whole point of this is to see how you can now build applications, build software with the tool that you already know. And the idea of this is that, especially when you're looking at React and this rendering mechanism, how that things work, as a way to know what is the problem that this tool solve you, and how you can now integrate that to your entire workflow. Okay, how does it fit here? So after we look at the rendering mechanism, which is the hardcore part of React, okay, and then how you can now think your state as a snapshot. So during when you're updating your state inside of your event handler, now there is synchronous, which means that you can think that your state is fixed. If you want to now update your state a series of queue updates, you can do this using an arrow function for that. And also, when it comes to updating your state, updating objects and array and states, the TLDR is always return is a new state out of this. You can use IMER as a way to make your state update consist. Your state update logic consists. So by using a mutable syntax. And then I look at now how can we create these components in a scalable way. How so? By looking at how you can manage your state. Because at the end of the day, the idea of using now this state is to see how you can now think of UI state or UI change as a state change, and how it's important to look at them and visualize all the different visual states. Then identify what triggered those state updates, and then represent those states using the user state, avoiding unessential states, and then update your states inside of your event handlers. So this is just to develop a notion of what we need to do, especially as we're going to build this UI and how we're going to now manage our UI. There are some principles that React come up to actually solve that particular problem. For example, like which is a concept from database normalization, which is just a fancy name to say eliminate redundance and duplicate data. Okay, we want to be fit and slim. We want to make we want to make an efficient use of our resource in terms of space and storage. And then how, when it comes to actually use that state and share that state through the different components, now we're starting to think about how React actually allows us to create these UI elements. And by first you need to have is the JSON models or the data model or the UI layers provided by the UI designers, and then you started to build now the components hierarchy. So if you have the data model, that is great because naturally it falls into that piece. But the whole point of this is to write in this static version, which is, even though that it requires a lot of typing but less thinking, if you use this data model, is something quite convenient, because the next phase is to now think about and determine what is the minimal representation of of a UI state. And that is, what is the minimal representation? What is the minimal data information that we need as a way to remember or store that or keep track of this? So here's when we now say, or a couple, the way of how you can now define this is by, hey, is this data or is this information does remain unchanged over time? So that's not in a state. Is this state comes, or is this information come from its props? That's not in a state. If this information can be or comes from a state, that's not in a state. Is this information can be computed from its props or the states? That's definitely not in a state. What left probably is in a state. And then you have to now decide is where your state should live, and that is would it make much more sense for your state to live. So usually you're going to define is your state to the closest pattern possible, or if by using is that state doesn't make sense to define them inside of the component, you can create as a component solely for the purpose of store that state. And how now then you do this inverse data flow, which is how you can now is pass down data, the state and the handler, as a way to now deal with that information. So we looked yesterday at how can we do that, all right? Especially in we have fibers. Oh, it was on the okay. It was on the It was mainly on the React TypeScript But we'll look at how can we do that. Resource, course repo. Okay, I got it. All of this. Duplicate this. Okay. But we'll look at that. React is now available. React blog. React comes 2024. Latest week. They actually now in release candidate. Okay, in the React 19 upgrade guide, what is new in React 18? You got now the things called actions, which is another hook, I'm assuming. A common use case in React app is to perform a data mutation and then update the states in response to that. For example, when submit a form to change their name, you will make an API request and then handle the response. In the past, you will need to handle pending state errors, optimistic updates, and sequential requests manually. Exactly. You set pending false. You have to do that manually. In React 19, we use this now transition for that. Because use transition, you can use transition to handle the pending state. Again, because after all, use transition, if I recall that, it allows to deal with concurrent rendering, which means that it doesn't block the main thread. It's pending and start transition. And start transition is a function. The async transition will immediately set that. Set the is pending state for that. By convention, functions that use async transitions are called actions. By convention, functions that use async transitions are called actions. Actions automatically manage submitting data for you, pending state, optimistic updates, error handling, and forms. Okay. Building on top of the action, React 19 introduced use optimistic to manage optimistic updates and a new hook called reuse action state to handle common case for actions. In React DOM, we're adding forms actions to manage form automatically and use form status to support the common cases of action. But again, this is to solve a specific problem for them. Use action state and then React DOM form actions. React DOM new hook use form status. Okay. New hook use optimist. Of course, the using is all of this is just as a way to actually solve the Facebook problem without relying in any other library. New hook use optimistic. Optimistic name. In new API use in React 19, we introduce a new API to read resource in render use. In comment process. Use will suspend until the promise result. In other words, they're using is generator. In other words, using is generator for that. Use does not support promise created in render. React server components. Full stack React architecture. because again, that's what they're pushing towards it. Start a new React project. Which features make up the React team full stack architecture vision? You know? And they're going to push that boundary, bro. Next app router bundler fully implementing the official React server component specification. This lets you mix built-in server only and interactive components in a single tree render. Holy moly. Built-in server only and interactive component. For example, you can write a server only React component as an async function that reads from the database or from a file. Then you can pass data down from it if your interactive component. Next.js and app router also integrates data fetching with suspense. This lets you specify a loading state like a skeleton placeholder for different part of your user interaction in the render tree. But again, they are pushing that. They are pushing is that start a new React project. And now, how you like it or not, you like it or not, you will need to actually. That's what they're doing. That's what they're doing. This is not your tool. This is the Facebook tool, and they're actually solving their own problems, and I get it. Server action. Improvement in React. Server action. Context as provider. Oh, okay. Cleanup function for ref. Use the fair value. Support for document metadata. Support for style sheets. Support for async script. Support for preloading resources. Compatibility with third-party extensions. Better error reporting. Support for custom elements. Server-side rendering and client-side rendering. But again, that's remove prop types and default prop for functions. Okay. Check the props. Okay. Remove strings ref. Remove model pattern factories. Remove deprecated React DOM APIs. Remove React DOM render. To use a creator. remove react done dot hide rotate. Element dot ref strict mode change. UMD will remove. TypeScript change. Clean off reference. Change the React element TypeScript type. The GSX namespace in TypeScript. Better use reducer typing. Oh yeah. Again, this is not that is identical to 18.2 but adds warning for deprecating APIs and other changes that are needed for React 19. We recommend upgrade to React 18.3 first to help you identify any issue before upgrading to React 19. That's one of the reasons why it's like once you learn in this, there is nothing wrong with this, but you know that actually none of this belongs to you. You know, you don't own this, and it's because you don't own this is like and it's because you don't own this is like hey, God, Jesus, thank God for this, man. And that was released not that long, bro. Jesus, in March. That's one of the things. That's one of the things of this. It's like, I mean, this technology is not yours. You need to keep up the pace with that. And it is sometimes quite better to, instead of relying on a framework, go with the language itself. Go with the language itself, bro. This is just my recommendation. In this case, go with JavaScript. If you want to go with or jQuery, and I get it why a lot of people actually are using jQuery and they stick to jQuery. Yeah, totally. And I know why people actually stick to jQuery for that, man. And I get it why people actually are doing is this. jQuery UI and jQuery mobile. This project is deprecated. QUnit infrastructure lead, core lead, globalized lead. Holy moly, bro. But I get it why a lot of people are actually using is this. jQuery UI is in maintenance only mode. and jQuery mobile is deprecated. Sysl and key unit. This is testing JavaScript. I get it. And I get it. But yeah, that's the thing that and all of these tools, especially completely. So learn the fundamentals. Learn the fundamental, master the fundamentals, and then you can come up. And the fundamental here is the data structure and algorithm. So as I move on here, okay, and now to understand and to develop a sense of what this tool actually is, especially when it comes to now maintaining an state or managing an state, pass down data or pass down state to other components, how now React is tied. So how now React tie the state to the position of the render tree, which means is that it allows you to reset or preserve the state of a component, and how you can do that. Also, when it comes to React to, so the more input that you need to react to this component, or the more input a state needs to react, how helpful it is to use a reducer for that. And when it comes to pass down data to distinct components, how helpful content it is to do that, especially the longer the chain you need to pass down that data, the more helpful it is to use context. But there is some caveats, and that is, there is some caveat, like you want is to only use context as a way to now share small app level data, analytics, authentication, theming. You want is, for example, is to combine with reducer as a way to now make it much more, as a way to make your state updates maintainable. But the caveat is that anytime, depending on the position of when you define your context, okay? So React will re-render all of the child components that use that existing or that specific provider, starting from the provider that changes that value. So as a way to prevent that, we use some built-in tools like use callbacks or use memo to do that. So use memo as a way to catch computations between re-rendered, as long as they are an array of dependency, or the callback. So you want us to catch is functions reference between re-rendering, and only when those array of dependency change, okay, you're now going to perform is all of this rendering cascade through the entire subtree that the provider is in. So again, this is now as a way to how you can make all of your state update logic consist in easy to maintain. But when it comes now to connect to other services, or when you need to connect to external services, so for example, you want to focus, you want to input focus using the web, you want to focus the input using the browser API, or play and pauses the video player without React, or perhaps you want to now connect and send some message to a server. So all of this which is known as the escape hatches. Okay, uh, most of your application shouldn't rely on this logic. Most of your application data. Um, mhm. Yeah, so most of your app level state, exactly. So most of your app level data, mhm. So most of your app level data, as well as, yeah, most of your app level data, and yeah, so most of your app level data and your in managing your logic shouldn't rely on these features. So we went through describe is how can we use ref as a way to remember things without triggering and re-rendering. Useful for the timers. Yeah, useful for the time ID, or manipulate a DOM elements, or when you need a JavaScript, or when you need an object that is not needed or that is not part of the rendering of the GSX calculation, you can use that. Uh, and when it comes now to connect to external systems as a way to synchronize with that, we use effects as a way to now run this side effect code, which will alter the state of our programs that is was primarily designed. So, for example, this side effects code, it can alter the global variables or a data structure, or can or perform input and output operations. So, for example, calling to a server and send a request to server and get that data from the tweet. If you're talking to a Twitter, now because of this piece of logic, and how you can now understand when you're writing your components, uh, how helpful is for us to know what is the rendering logic, or what is the logic inside of, what is the type of logic inside of our React components, the anatomy of that, which is you have now is the rendering logic, which must be pure, and then you have inside of your event handler is when you can perform these side effects. So React say we want to perform now this side effect code as caused by rendering itself, and this will fit is after the commit phase. So usually uh, you might not need an effect if your state, if you need to update a state based on another state. But when it comes to now synchronizing with another external system, okay, we look at now the anatomy of the use effect, which is the setup function and the setup function and the cleanup function, okay, where initially you're going to now run this side effect code after every commit phase as part of the component rendering itself, after every commit phase. But usually you don't want to do that. That's why you pass now an array of dependency and you define as a cleanup function. Because in React 18 they're using is now strict mode, which is a way to prevent some common gotchas like in your state or your side effects. They rerun your effect and re-render your components twice. So when you're writing your use effect, it is important to think, especially in development, how you can fit that to work with the cleanup function, because of this strict mode that we mentioned here, it will call your components, it will re-render your components twice, as well as your effect or your side effect, which means that it's going to trigger is the cleanup function, the setup function, cleanup and setup. So the idea is that once you get familiar with this in development mode, which is not going to happen in production. In production, you just only trigger is the setup function, okay? And the idea of now looking at when you write your effects, what will typically fall, okay? So when you write your effect, what will typically, in which particular pattern it will fall? So whether it is connecting to an external widget, or an animation, or subscribing to events, or in data fetching, which is something that is not trivial, like navigation, because now here you need to handle is how you can now undo network operations, because there is no way to actually undo that. So that's why we need to put is the flag that is saying, hey, I want you to prevent some race condition, or a flag that actually say that's going to ignore this function, all right, if this is an stale data, which means that if this effect run caused by a synchronization, I want you to get rid of the data. And this is something that involves not only this particular challenge as a way to prevent these race conditions, but also as a way to prevent these race conditions, but also all of this the specific challenge involved here, which is, all right, there's a way as a way to prevent all of this specific challenge here. So wait a single moment. Okay. Yeah, as a way to prevent all of this specific challenge here. So, as a way to prevent all of this specific challenge, when it comes to actually doing data fetching, which is, well, because this effects only runs on the client, not on the server, so you need to avoid the duplicated network requests, because now the client needs to send a request, the server render that content, send that over to the client show the loading page, now it requests again to download the JavaScript to add interactivity, only to realize now that it needs to actually make an HTTP request. So that's not ideal. And also you have to avoid any network requests, the waterfall network request, because it's several components actually are making HTTP requests, so your page will slow down heavily. So an example of that is, if you have your bank account, right, and you're showing is the balance accounts and the transaction history, as well as the profile data, each one of those components actually fetch data. So they actually need to find a way to avoid the duplicated net requests, as well as waterfall requests. And also you need to find a way to catch that data, because anytime you or the user actually get out of the app and get in, you don't have that data catch. So not only that, you also need to handle these race conditions. So for example, if you are now is finding, if you want to in real time find is yeah, if you want in real time find is uh, mm-hmm. So if you want to find in real time is data, let's say you want to know is the transaction history from certain date to another date, or you want to know is the name, you want to find is a specific sender name, okay, or deposit name in your transaction history. You want to do that in real time. You want is to somehow is anytime the user is typing or back or doing backs or doing a backspace or delete that, you want to know somehow is that how you can actually is wait for that or doing some trolling. Okay, so on that, okay, the whole point of this is to see that data fetching is not a trivial things, pretty much like navigation or routing, okay, and there are already solutions that now frameworks like Next provide for you. So for example, like uh, so Next, Remix, Gatsby, or client-side data fetching such as USWC in USWC in okay, so USWC okay, like USWC okay, like exactly like USWC, React Query, and React Router. So then I also look at the specific use case using analytics, okay. And when it comes to see when you need an effect or not, it's like if you don't need to synchronize to an external system, you might not need an effect. Period. Period. So if you need to compute or if you need states based on another or states, or if you want to change your states, something they mentioned here. Okay, so updating states based on props or another, updating states or props based on another states or props, you might not need an effect. You can compute that. Catching, you use a built-in hook. Resetting all the state, you use the key property or you render that component in a different state. Sharing logic between event handlers, you don't need an effect. You just abstract that logic and put that into a function that you can share with different event handlers. Sending a post, you don't need an effect. In fact, you do is an event handler. Change of computations. So this is you want to actually giving a particular attribute, change that based on that. You don't need an effect. You in fact you define your logic inside of your event handlers, and it's in there where you're gonna do that. Data fetching. This is when you need an effect. In subscribing to external store. So for example, subscribing to external store where React doesn't know what's happening, such as an external, such as an external event API, for example, like notifications or network, or subscribing to a particular event, whether it's the mouse event, mouse move, mouse over, and that kind of thing. So there's already now a specific hook to deal with that. And when it comes to look at the life cycle of the React effects, how now this fits when you write your components. So this is different from the component. So your components life cycle is you mount, update, and then you unmount. Where now here, your effect is important to think of them that do only two things. You can either start a synchronization process and later on stop synchronizing. And this process can happen multiple times, depends on how often your props and your states change. And the React provide a linter to specify the effects dependency correctly, which means that this keep your effects synchronized to the latest props. So here we look at now the anatomy of the effect, the setup, the cleanup function, as well as the array of dependency, when this is, and how to think about your effect as a synchronization process. So think of this also as a separate synchronization process. Okay, so for example, if you're dealing with data fetching and analytics, and anytime you are doing that data fetching or analytics, you want to keep track of that. Put that in a separate use effect, and because now this code will rerun whenever your dependency change. They must be reactive values, and reactive value is whatever you define inside of your component, whether it's an states, a props, or values you define inside of your component. So when those values, and they call reactive because usually they will change over time. So when those values change, now React compare that with the previous state using the object.is as a way to say, all right, now let me actually run this code after the commit phase. So that's quite interesting. Okay, that's quite interesting. But sometimes you don't want to actually synchronize. Okay, sometimes you don't want to synchronize some of your variables that you're passing to your effect. And when that happens, you, instead of putting that variable or that value inside of your component's body, you put it outside of the function. And sometimes, because you might end up, because you don't choose, remember that the logic inside of your effects are reactive code block. Okay, which means that they're gonna be run based on an array of dependency whenever they change, which means is that if you, for example, don't put a correct or your effects are running in an infinite loop, somehow there's a couple of things that you can do. Or you either split your, or you might not need an effect initially, or you split that effect into separate synchronization process. So sometimes you want to now is have the ability to read and write variables without reacting to that, but keep the synchronization process. And this is a very specific case when now they talk about separating events from effects. So in your effects, you want to run now this reactive logic, and in your events, you want to run now this non-reactive logic. And also never put these objects and functions in your array of dependency because they change over time and they will cause you an infinite loop. So in this specific case that is again very narrow specific to React and Facebook and that kind of thing. Event handlers only rerun when you perform the same interactions again. That's right. Totally comprehensible. Event handlers, event handlers only happen. Event handlers only reruns when you perform the same interaction again. That's right. Oh shit! I don't know what happened to me, but yeah, I guess. So event handlers happen whenever you do event handlers runs. Um, Event handlers runs whenever you perform the same interaction. Okay. So event handlers rerun whenever you perform the same interactions. Unlike effects, when they only run when you need to synchronize or as a resynchronization if some values they read like props or states are different during what was the last render. Okay, so the question is that what is the main use case for this? What is the main use case of using or separating its effects from events? Because event happens um, whenever you perform the same interactions. An event happen whenever you perform the same interactions. And effects as a resynchronization process. Okay, which is when the variables they read, like props or states, are different from what was last during the previous render. So sometimes you want a mix of both behaviors, effects and that rerun in response to some values. So choosing between event handlers and an effect. And I want to know is what is the specific use case for this? Event handlers run in response to specific interactions, and effects run whenever a synchronization is needed. Okay, so reactive values and reactive logic is something that you put inside of your well, this is when they describe this. Prop states and variables declared inside of your component body are called reactive values, like so. Reactive value like this can change due to a re-render. So logic inside of your event handlers is non-reactive, but logic inside of your effects are reactive, which means that they're going to trigger whenever this props or a state changed. Okay, and this is now logic inside of event handler is not reactive. Logic inside effect is reactive. So from the user perspective, a change to the room ID does not mean that they want to connect to a different room. In other words, the logic for connecting the room should be reactive. You want this line of code to keep up with the React values. And to run again, if that the value is different, that's why it belongs to an effect. And then you say extracting non-reactive logic out of the effect. Things get more triggered when you want to mix reactive logic with non-reactive logic, which is logic that happens caused by a logic that happens caused by performing the same effects. Okay. Logic that happens as a consequence of the same effect. Logic that happens as a consequence of the same effect. And the other is that non-reactive logic. And for example, imagine that you want to show a notification when the user connects to the chat. You read the current themes, dark or light, from the props so you can show the notification in the correct color. Like so. And then you're going to show the notification. Again, we want is to show now is not as a part of the synchronization, but when the specific user input happen. However, theme is a reactive value. It can change as a result of re-rendering. And every React value read by an effect must be and every React value read by an effect must be declared in the array of dependencies. Now you have to specify the theme as a dependency or your effect, but in this case you want it to only run is you want to run is a specific logic. You want to run is a non-reactive logic or an event handler logic, which means is a event that happens caused by the same interactions, not that happen when you need to resynchronize something. And in this case, with this. So play with this example and see if you can spot the problem with the user experience. So of course, because you change to travel, that's right, you're not connected. And the thing is that you use dark theme, you say, hey, I am connected. But the whole point of this is that I don't want to actually show this connected logic. It just only uses the dark theme or not. So giving a specific user interactions. I want you to now mix the reactive logic, which is the reactive logic or the effect, which is caused by a resynchronization process, with the user interaction or the event handler, which caused by performing the same interactions. Which is in this case clicking that. Okay. So how you actually connect this shit with that? So when the wrong ID changes, the chat reconnects as you would expect. But since the theme is also a dependency, the chat also reconnects every time to switch between the dark, and that is not good. Because we don't want to resynchronize that. We don't want to trigger a resynchronization based on a user interaction. And declaring an effect. This section describes an experimental API that has not been released in a stable version of React. And this is now an experimental. Again, this is just as a way to understand what is the main problem that this wants to solve. This API is experimental, it's not available in a stable version of React yet. Okay. API reference, experimental. And they don't even include that. Okay. So if you use an effect like this, when this, as a way to connect, as a way to now trigger this particular logic as cause of an state update here. Okay, you want to combine now an event with a reactive logic. Okay, you want to combine is a reactive logic with an event. A reactive logic with an event. Okay. Again, this is something in alpha. There is no actually need to do that. But let's go to move on to the removing effect dependency. And here, when you write an effect, the linter will verify that you include everything reactive value. Let me see here. Okay. Removing effect dependency. When you write an effect, the linter will verify that you include every reactive value, like props and state, that the effect reads in the list of your effects dependency. This ensures that your effect remains synchronous. Okay. It's like when you write an effect, this is not to solve this specific problem, especially when you have now is when you have now is this is to solve a specific problem. When you want to know is this is to solve a specific problem, you know. This is now to solve a specific problem. Yeah, like so. So this is now to solve. Yeah, this is now to solve a specific problem. Okay. So this is now to solve any specific problems. I get it completely, man. Okay. This is now to solve a specific problems. Is this sometimes your effects is running in a loop because you define too much you define too much reactive values, or some of those reactive values are actually causing you that effect perform a loop. Okay. And this ensures that your effect remains synchronized. So when you write an effect, the linter will verify that you include every reactive values, like props and state, and that the effect reads in the list of your effects dependency. So this ensures that your effect remains synchronized with the latest props and state of your components. So anytime the components re-render, so anytime the effects dependency change, the linter will verify that you actually are reading the proper reactive values, states, or props inside of your event, inside of your effect logic. But sometimes unnecessary dependency may cause your effects to run too often, or even create an infinite loop. Follow these guides to review and remove unnecessary dependency from your effects. You will learn how to fix infinite effect dependency loops, what to do when you want to remove a dependency, exactly how to fix infinite effect dependency loops, what to do when you want to remove a dependency, how to read the value from your effect without reacting to it. Wait, what? How to fix an effect dependency loop? What to do when you want to remove a dependency? How to read a value from your effect without reacting to it? how and why to avoid objects and functions dependency, why suppressing the dependency linter is dangerous, and what to do instead. Dependencies should match the code. When you write an effect, you're first specifying how to start and stop. Exactly. Started defining is the synchronization process. How you start and stop. Whatever you want your effect to be doing. In this case, the setup code like this, followed by the cleanup function. If you leave like this, the linter will suggest to correct the dependency. Why is that? Because there are some variables that you are reading, and one of them is reactive, which is here, room ID, right? And now it say, all right. So when this variable change, I'm going to actually update the screen blazing fast. So export the default app like this. So we were able to actually do this. Filling the according to what the linter said. But again, the linter is helping you to now when you're running your effect logic, and if you're using some reactive dependency, hey, you need them. Okay. Effects reacts to reactive values. Exactly. So your effect logics react to reactive values. That's what they call is reactive logic. Since room ID is a reactive value, it can change due to a re-render. The linters verify that you have specified as a dependency. If room ID receives a different value, like this, if room ID receives a different value, React will resynchronize your effect. This ensures that the chat stay connected and select rooms and reacts to the dropdown, which is like this. So the effects react to reactive values. Or in this case, this logic reacts to reactive values. And reactive values are props, states, or any variables that you define in the components body. Okay. So far, so good. So to remove a dependency, prove that it's not a dependency. Completely. So if you want to remove a dependency, prove to the linter that it's not a dependency. And in this case, React hook use effect has a missing dependency here. Reactive values include props and all variables on the function declared directly inside of your components. Since room ID is a reactive value, you can remove it from a dependency list, and the linter wouldn't allow it. And the linter will be right. Since room ID may change over time, that's what you need. You can also put it outside of that. So you have to prove to the linter, hey, that is not a reactive dependency. Prove to the linter that is not a dependency, a reactive dependency. So now you only have to do like so. Okay, so when you want to do this, say travel. Alright. It's not changing, it is changing, but based on what is being rendered in this component when it gets rendered. So it is evaluating this file as the entry point. This is why you could now specify the empty array of dependency. To change the dependency, change the code. You might have noticed a pattern in your workflow. First, you change the code of your effects or how your effects values are declared. Then you follow the linter and adjust the dependency to match the code you have changed. And if you're not happy with the list of dependency, you go back to the first step, which is change the code and change the code again. The last part is important. If you want to change the dependency, change the surrounding code first. you can think of the dependency list as a list of reactive value used by your effects code. And you don't choose what to put on that list. The list describes your code. To change the dependency list, change the code. To change a dependency of list, change your code. So why suppressing the dependency linter is so dangerous? So for example, here, ESLint disable next line React hook exhaustive. So here, you are now suppressing this and you say, hey, this is now on tick. But because this is a function, and this function will run once, okay? What happened here is that anytime you change this, anytime for some reason the render needs to calculate this, okay, it actually now called this. So you don't have control about this, because it's like assuming that this component has this new value here. So you're not reacting is whenever you're not reacting properly to that. Every second by the amount configurable by 2. But since this code now only run is on the when the code mounts, unless you remove that, it actually going to now call this over and over and over and over. Because now this use effect you're telling is like, hey, I want you to run this side effect or this effect code, this reactive code, after the commit phase forever, whenever this component is mounted. We recommend treating the list of dependency lint error as a compilation error and don't suppress that. So removing unnecessary dependency. You might want to re-execute different part of your effects under different conditions. You might want to only read the latest value of some dependency instead of reacting to its change. And so a dependency may change too often unintentionally because it is an object or a function. To find the right solution, you will need to answer a few questions about the effect, and let's walk through that. Should this code move to an event handler? If your effect's doing several unrelated things, again, this is a synchronization process, and you don't want to fetch your data unless it actually changes. Create a single independent process. Exactly. Which means that in this case, extracting repetitive logic into a custom hook. Are you reading some state to calculate the next state? Do you want to read the value without reacting to this chain? This is under construction. Does some reactive value change unintentionally? Exactly, because they are two different objects, which means that there are two different locations in memory. Objects and functions dependency can make your effect resynchronizing more often than you need. In JavaScript, each newly created object and function is considered distinct from all other. It doesn't matter the content inside of them may be the same. So that'll be all for this video. Take care. Bye bye.